Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, Louis in Weston at 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind adjust the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, Louis in Weston.
My research goal was to show that the impossible to massively parallel process was in fact possible to massively parallel compute and compute at 65,536 commodity processors that communicated synchronously while computing simultaneously. At its calculus and algebraic core, the extreme scale petroleum reservoir model, as posed in the geophysics textbooks on porous media flow of the 1950s, 60s, 70s, and even 80s, was an extremely computation-intensive problem that was classified by the US Department of Energy as one of the 20 grand challenge problems in the field of supercomputing. The extreme scale petroleum reservoir model begged to be massively parallel processed and to be computed across millions of commodity processors. The reason the extreme scale petroleum reservoir simulation was classified as a grand challenge problem was because it was a holistic triple threat problem that traverses the fields of physics, mathematics, and extreme scale supercomputing. A research mathematical physicist that tries to solve a triple threat problem in science and technology and tries to solve it as a mathematics problem alone is like a triathlete that is trying to win a triathlon without competing in the swimming leg of the triathlon competition. Like that triathlete that can only run and ride a bicycle, that mathematical physicist that only understands mathematics and physics will get stuck in the extreme scale computation portion of the triple threat scientific problem. Think of the triathlete that registered for a triathlon race that begins in Enugu, Nigeria, and ends in Asaba, Nigeria. When I lived in Nigeria and in 1972 and 73, I commuted between Enugu in the East Central state and Asaba in the Midwest state of Nigeria. The triathlete that can only run and ride a bicycle can run from Enugu, Nigeria to Awka, Nigeria and run in a world record time. Then the triathlete can bicycle from Awka, Nigeria to my hometown of Onitsha, Nigeria and bicycle in a world record time. But if at the third leg, the triathlete was unable to swim across the mile-wide River Niger, then that triathlete, that is both the world's fastest runner and the world's fastest bicyclist, will become the world's slowest triathlete. The grand challenge problem of massively parallel supercomputing was the scientific triathlon that calls for a polymath that was a triple threat in physics, mathematics, and supercomputing. Neither a mathematician trained for only 8 years nor a computer scientist also trained for only 8 years could solve that grand challenge problem alone. They could not even collaborate to solve the grand challenge problem together.
Insightful and brilliant lecture.